Hello, today we have lesson 1.1, variables, tables, and graphs. First, we'll define statistics. So in terms of a subject, statistics is the science/math of collection, organization, analyses, plural analysis, and interpretation of data. In terms of just a number, a statistic is a number that describes a set of numbers. All right, it's a lot of writing for math class. So we have a table about inline skaters, which is essentially rollerblading, I think. So 2,145 inline skaters were chosen for a survey and asked to classify their ability and then say how much gear they were wearing. So we have our table. So we're going to pause for a moment and define some things on the second page that we will need to do that. So we have variable, population, sample, and representative sample. A variable is, sorry, just a little more writing, characteristic that can be classified, counted, or measured. And we have categorical data, which is, well, it's categories. What category are you in? For example, the skill level that we'll talk about in a second. Are you beginner? Are you advanced? Versus numerical, which would be like, how old are you, right? That's a number. A population is the set of all individuals or objects, depending on what you're looking at for your statistics, you want to study. Sorry, my writing's getting a little crooked. A sample is a subset of the population. And a representative sample is a subset of the population that has the same characteristics as the population. So for example, if you were looking at Edina High School and you wanted to survey and figure out how many students love math, if you only surveyed 9th graders, it would not be representative because the high school has all 4 grades, for example. So if you wanted a representative sample, you would have to survey people from all grades. So back to the inline skaters. So we're looking at this. Is the data based on a sample or the entire population? Well, if we look at this, we had selected inline skaters. So we're assuming that not all the inline skaters or the rollerbladers were surveyed. So we're assuming it's a sample because it's not all skaters. Sometimes it requires a little assumptions, but as long as you're making good assumptions, you're okay. What variables are presented? Well, we have skill level and we have amount of gear. And both of these are categorical variables because we're looking at, did you wear no gear? Did you wear 1 piece, 2 to 4, or and beginner, average, advanced, total. It's kind of tricky because the amount of gear, it is numbers, but it's written in terms of like no gear and then 2 to 4. So they really are categories. So we want to look at not first, we've already done A and B. Part C, how many skaters said they were advanced? Well, let's look. Here's advanced, go all the way over. 754 skaters said they were advanced. Because there were advanced, no gear people, advanced 1 piece, advanced 2 to 4, totaling 754. Now we're looking at how many advanced skaters wore gear. Well, now we want to look at out of this total 754. So really we're just focusing on this row right here. We're looking at out of those 754, how many wore some gear. So the no gear people don't count. So we have the 1 piece and the 2 to 4. So it's 242 plus 140, which is 382. Next we have what percentage of skaters wore no gear. So we're looking at the total skaters. So total skaters was 2,145, so that's going to be our denominator. And how many of them wore no gear? 874. These are the no gear people. So 874 divided by 2145. If you put that in your calculator, you'll get 0.407, unless you want to do long division, but I don't really. So that's about 41%. And then we have what percent, but we're not going to say of beginners. We're going to say what percent of advanced wore no gear. And so we're looking at all the people that were advanced. Switch colors for a minute. All the people that were advanced, which was our 754. And we're looking at how many of those were no gear. That's our 372. So we have 372 divided by 754 is 0.493, or about 49%. Remember, to find percentage from a decimal, you're multiplying by 100, which is moving the decimal place to the right 2 places. So a medical laboratory technician draws 10 milliliters of blood in order to determine the number of white blood cells in a patient's bloodstream. We want to find the variable population and sample. Take a moment, pause the video, write down the variable, population, and sample, and decide whether it's a representative sample or not. So pause the video, please. Okay, so our variable was the number of white blood cells. Our population, this is kind of weird, but our population is all the patient's blood. So like everything in the patient's body, that's the population of blood. And the sample, is the 10 milliliters of blood that was drawn. So it's like you're looking in your whole body and you're like, well, I can't test a person's whole body's worth of blood, so I'm going to take 10 milliliters. That's the idea. Okay, so for the second example, I would like you to pause and try to do this on your own. That's going to be the best way to do it. That's what I would have you do if you were in class. Okay, I'm assuming you tried to do it. So let's go through it. What are the variables, sample or population? So the variables are highest level of education, highest educ level, and percent distribution by income level, or annual household income, essentially, because that's what you're looking at. Okay, sample or population. So this one, it's a little bit of a trick. So this is the U.S. Census Bureau a while ago in 2006, but either way, this is the Census Bureau. So then we're assuming population. just because the census should get everybody, and if it doesn't, that's okay. We're going to call it population. So let's look at the entry 31,153. There it is. What does it mean? Well, this just means the number of because look up here, this is the number of households with a bachelor's degree or higher. And keep in mind, this is in thousands, so it's not 31,153 houses, it's 31,153,000 households. Households, not houses. And then what percent of households had an income of at least $100,000 if the head of house graduated college? So if the head of house graduated college is going to be like our total that we're looking at. So head of house graduated college, we're assuming that graduated as bachelor's degree or higher. Some college doesn't count. And I was thinking we had to calculate a percentage, but we don't, because this is percent distribution. So we look at bachelor's degree or higher, and we go over here, $100,000 or over. And this is in percents. So it's 36.2%. And that's all for notes for today.